Hi, myself Dr. K. Ashok, Associate Professor of Physics, Marri Reddy Institute of Technology and Management. Today I am going to discuss about the solar cell. So, what is the main importance of this solar cell? The solar cell we are using in our everyday day-to-day life. Where we are using, suppose you take a calculator. In the calculator we are using for supplying power. Even you consider a watch, wristwatch. Everywhere we are using solar cell. First of all, what is the function of solar cell? Basically, solar cell converts solar energy into electrical energy. It is based on photovoltaic effect. It is based on photovoltaic effect. In the name only it is there, photons. Photons are converted into voltage. So, here solar cell is based on photovoltaic effect. It converts solar energy into electrical energy. When you consider the symbol of solar cell, which looks like very much similar to PN junction diode only, but here we are representing light is taking. See, arrow mark is important. When we consider LED, the light symbol, these arrow marks are moving outward. Here we are showing this device converts optical energy into electrical energy. Basically, a PN junction diode, basically solar cell is a PN junction diode. So, what is a PN junction diode? P-type semiconductor we obtain here by doping silicon with trivalent impurity. Trivalent impurity means aluminum. N-type semiconductor is obtained by doping silicon with pentavalent impurities. Pentavalent impurities means take it as phosphorus. When we doped P-type semiconductor with trivalent impurities, majority charge carriers are holes. When we dope pentavalent impurities to intrinsic semiconductor, majority charge carriers are electrons. This P side and N side we are attached together to form a PN junction diode. Whenever a PN junction diode is formed, at the junction, depletion layer will be formed. This is the P-type and this is the N-type. Here, the depletion layer is formed. This is called depletion layer. What is the meaning of depletion layer? Where the charge carriers gets neutralized. That region is called depletion layer. Here, N side, we will have donor ions. P side, we have acceptor ions. Acceptor ions are trivalent impurities. Donor ions are pentavalent impurities. Then a barrier potential is developed and certain electrical field, barrier field is generated. So, in order to move these holes to this side or electrons to this side, compulsory you have to supply additional energy. This is about the PN junction diode formation. In our case, this PN junction diode we are using to convert solar energy into electrical energy. How it works, that I will discuss. Whenever radiation interacts with matter, three phenomena takes place. Assume it as this is the ground level of energy E1. This is the excited level of energy E2. Whenever we supply an energy which is equals to difference of these two levels, E2 minus E1, let it be roughly H nu. Whenever we supply the energy which is equals to difference of these two energy levels, the electrons in ground level absorbs the energy and excited to higher energy level. This process is called, the electrons are moving from first level to next level. This process is called absorption. After certain intervals of time, this electron will fall from higher energy level to lower energy level by liberating the energy. If you consider they are direct band gap semiconductors, this de-excitation will release the energy in the form of light or optical energy. If you consider this as indirect band gap semiconductor, the transition of electron from higher energy level to lower energy level liberates the thermal energy. Thermal energy, nothing but phonons. This already we studied in previous class. So this phenomenon plays a major role because in order to convert optical energy into light energy, the major role here is energy gap. Different materials available in nature, silicon you consider the energy gap is 1.1 electron volts, means the gap between valency band and conduction band is 1.11 electron volt. Suppose if this is the valency band and this is the conduction band, so the energy gap is 1.1 electron volts. You need to supply an external energy, okay, that should have at least 1.1 electron volts, then only, okay, electron will excite from valency band to conduction band, then hole is produced in valency band and electron is appeared in conduction band. So this is called generation, carrier generation. If you consider cadmium tellurium, here the energy gap is 1.49 electron volts. So here you consider gallium arsenide 1.43 material. Our main target is to convert solar energy into electrical energy. Solar energy is nothing but a spectrum of radiation with different wavelengths. But when we consider IR, visible and UV, this is our range where we want to convert energy. When you consider visible light, so whenever you want to convert visible to our electrical energy, then at least the spectrum should have, the spectrum of energy is around 1.5 electron volts. This is visible spectrum energy I am talking. So this energy range roughly, if you observe here, gallium arsenide, but gallium arsenide is the little costly material. That's why we are preferring silicon in manufacturing of solar cells. The P-type semiconductor and N-type semiconductors we developed by using silicon as the host material, as which is the chief material which is abundant on the earth. So now if we observe a PN junction diode, this is a PN junction diode, this is P-type and this is N-type semiconductor. Here the depletion layer is formed. In P side majority charge carriers are holes and in N side the majority charge carriers are electrons. N side majority charge carriers are electrons and this is nothing but barrier potential. Now here what we are doing means we are exposing this PN junction diode to sun. Whenever you expose, then light is falling. Here when you observe in the depletion layer, there are no charge carriers are available. Silicon, in this depletion layer, the silicon atoms is covalently bonded with silicon atoms, neighboring silicon atoms. These are the covalent bonds. Whenever you incident a light which is having sufficient energy, this covalent bond breaks down in depletion layer. When covalent bond breaks down, electron hole pairs are generated. After certain intervals of time, these electron hole pairs will recombine. But before recombination, here what is there? Some barrier field is there. This barrier electric field will swept out this electron towards the N side, this hole towards the P side. When we are incidenting the light on the solar cell, electron hole pairs are generated in depletion layer. These electron hole pairs are drifted in opposite direction. Because of this drifting, more number of charge carriers accumulated on N side and P side. In N side, more number of holes are accumulated. In P side, more number of holes are accumulated. In N side, more number of electrons accumulated. If you increase the brightness of the light, brightness is increasing means number of photons you are increasing. Because of the number of photons increasing, number of electron hole pairs generated in depletion layer. Simply, the intensity of the light is directly proportional to number of electrons and hole pairs. Number of electron and hole pairs directly. If you increase the more intensity, more number of electron hole pairs are generated. If you decrease the intensity, less number of electron hole pairs are generated. This scenario continues up to certain intervals of time. Then again, if you increase the intensity of the light, what happened, in P side already more number of positively charged carriers are there. Here more number of negatively charged carriers are there. After certain intervals of time, what happened means this electron is repelled by the negative charge and towards the same side. And even this hole is whatever generated here, this hole whatever generated here wants to move this side, but here positive, more positivity, this hole is again reflected back. So this particular voltage is nothing but open circuit voltage. Open circuit voltage means this is the maximum voltage developed in the solar cell. If you want to increase more voltage, then what you have to do, you have to increase the size of the P side and N side semiconductor. If you want to increase open circuit voltage, you have to increase the size of the semiconductor. Here this is about the P-type semiconductor and N-type semiconductor. Because of the incident light, because of this light incident, more holes are appeared on the P side and more charge carriers more electrons are appear on the N side. More holes on P side and more electrons on N side. Now without connecting any resistance, if you short circuit this N and P, what happened? Simply these electrons starts moving from here to here and here the recombination takes place. Whatever this current without any resistance or load, whatever the current is flowing, that is called short circuited current. These two, like open circuit voltage and short circuit current, plays a vital role in output whatever the efficiency we are expecting from the solar cell. Here presently, if you observe, the diode is not any biasing is happening. Why any biasing we are not happening means solar cell in the name only itself is there. We want to use it as a battery because positive charge and negative charge separated by certain distance, so voltage is developed. This is about the solar cell working. What is the solar cell working? Whenever light of sufficient energy is made to incident on the solar cell, electron hole pairs are generated in depletion layer. These electron hole pairs are swept out swept in opposite direction because of the barrier field. So like that the voltage is developed in solar cell. So this is about the conduction band environment. Whenever light of sufficient energy is incident, then electron hole pairs are created in barrier potential. You can observe here, this is the barrier potential. After that, more number of electrons are moving N side, more number of holes are moving P side. In this manner, it is acting as this side more negative and more positive. Positive and negative separated by certain distance, electric field is developed. So this is about the different types of materials available in nature. So when you consider monocrystalline material, here the efficiency, what is this efficiency? Number of photons incident on the solar panel and they are converted into electron hole pairs. Suppose 100 photons are incident on the panel, just only 14 to 17 only converted into electron hole pairs. This is already we discussed. The spectrum has the range of 0.5 electron volts to 2.9 electron volts, whatever the sunlight we are getting. But here we are using silicon. Silicon energy gap is 1.1 electron volts. So such type of the range, the photons having energy in this range only converted into electron hole pairs. Remaining all photons gets vanished because that energy is not sufficient to create electron hole pairs. So this is about the VI characteristics of the solar cell. So what are the major advantages of the solar cell? The first one is it is a renewable energy. So we can use continuously, and no fuel is needed. Generally, usually fuel is needed, but here no fuel is needed, and no fuels we are using, no pollution is produced because of the solar panels, and no movement of the parts are available in the PN junction diode. That's why no lubricants and all those are required. So very little maintenance only needed, and their long life. So once the solar panel is installed, so it can be utilized like 10 to 20 years continuously. Next, these are the main advantages. Coming to disadvantages, the first one is high installation cost. Initially, you need to keep high cost and low efficiency. Just now only we saw out of 100 photons, it is converting only 14 to 15 photons as the electron hole pairs. That's why efficiency is very low. We need to improve the efficiency of the solar panels. And next, night time, we cannot use solar panels as the radiation from the sun is very low. That's why we cannot convert that radiation into electron hole pairs. These are some of the disadvantages of the solar cells. Applications. So nowadays everywhere we are using, you can see in the pump sets also we are using solar panels. In your calculators also we are using solar panels. In traffic signals you observe, nowadays in traffic signals, bulbs point of view, we are using LEDs. LEDs consumes very low power. That's why solar panels are efficiently we are using in traffic signals and display boards also. So in domestic power supply, we are going to use, already we are using this one. The central government is giving some concession for usage of the solar panels, for encouragement of usage of the solar panels. And even for satellites we will supply our power simply by using solar panels only. In remote villages also we are supplying power by using solar panels. So these are the applications of the solar cells.